All right, this is section 6.1 called a normal distribution. So just in case you guys forgot what the normal distribution was, so this is our special type of curve, right? It's special because it's symmetric and nicely beautiful when it comes to it. So we're going to do far more in detail in the next couple sections of why this is so important and what properties we know based off this, portion here. Okay, so the first thing is let's talk about this more closely. Okay, now. When it comes to the normal curve or the bell-shaped curve, again, the normal distribution, the first we want to talk about is the mean is always equal to 0, and the standard deviation is always 1 in our case. So 0 is always in the center because that's the mean itself, and we know standard deviation-wise is always 1. Okay. Now, when it comes to the normal distribution, so this essentially is a number line starting at 0. So remember, you go back to number line, these numbers on the right-hand side are positive, these numbers on the left-hand are negative. So, for example, if I go over here, let's say this is 1, 2, and 3. This is -1, -2, and -3. Now, we talked about a little bit of this, right? The 1, 2, and 3 portion using the empirical rule. If we go area in between it, it's 68, 95, and then 99.7. Now, the thing is, these numbers on the bottom, these numbers themselves, are called z-scores. Okay, that's what's so special about them. So the numbers at the bottom are always called z-scores. Okay, and a z-score is a number that represents the number of standard deviations of values away from the mean. Now, here's the thing. Because now they're numbers, right, we have decimals between each individual number. So now I can say 2.33. So if I say a z-score of 2.33 means that a certain value is 2.33 standard deviations away from the mean. Now we know exactly how far it is, not just the 1, 2, 3 format here. Okay. So the main thing we're talking about right now is, for focus, just the numbers on the bottom are actual z-scores. That's what they're called, z-scores. Okay. And we'll talk about why they're more important in a little bit. But as of now, we're just talking about what does it represent area. Okay. So for instance, let's look at the concept of area. All right. So area is the concept of what's being, this piece of paper, how much space is being, used by this piece of paper. That's the concept of area. So if you look at the whiteboard, the whiteboard's area is how much space is being occupied by that whiteboard. So the thing is, right, that's the concept of area. Now we have equations to find areas given the different shapes and sizes we have. So for instance here, area of a rectangle is just length times width. So width and the length, correct? Now we can do that, right? So for instance, I have, let's say, a rectangle of 5 and 3. The area will be 5 times 3 gives you 15. Okay, so that's just an equation, but the whole concept of area is what's, how much space is it occupying on the surface. Okay. So the thing is, now I can put this on the XY plane to make it look like this. So if I now make my rectangle on the XY plane, I can ask you the same exact questions. Well, what's the area of this rectangle? Well, you're still going 5 units and up by 1, 2, 3, so total of 15, right? 5 times 3 gives you 15. Well, the thing is now, what if I didn't want the entire area? Let's suppose I just wanted this chunk here, the shaded region there. Okay. So now the question is, what's the area of the shaded region? Well, it's the same concept, right? It's length times width. So the width is still 1, 2, 3. But now what is the width? Or the length of width, right? So it's 1, 2. So the area would actually be 6, right? Okay. All right. Well, now here's a question for you guys. What is the area of the non-shaded region? So in other words, this part here. What would that area be? Okay. Well, it's the same thing, right? Length times width. So again, this is still going to be 3. But now times what? Well, how much is it going from here to here? Well, we just count, right? 1, 2, 3. So it's 3 units itself. So 3 times 3 gives you the 9. So one last question when it comes to it. Does the area of the shaded region and the non-shaded region give you what? So in other words, what is the area of the shaded region plus the area of the non-shaded region? And hopefully you say 15. So do you guys agree that the area of the shaded region plus the non-shaded area gives you the total area to begin with? And hopefully you guys say, yeah, right? Because there's no overlap. It's completely cut, like a slice, right? Cut right in the middle. Now I can do this anywhere I want, right? I can move this line here, however I choose. But hopefully you guys get the picture that, it's still going to be the same, right? This area plus that area gives you the entire area itself. Okay. Now we're going to put that on the back burner for now because we're going to talk about that in a little bit. But so we're going to do the same concept when it comes to area underneath the normal distribution. Okay. So now when it comes to the normal distribution, right, like this, we can do the exact same process. Okay. Now what we want to figure out is what is the area underneath the curve. Now the problem is, right, we have an equation for that here. Unfortunately, when it comes to area underneath curves, we don't have formulas. Well, we do, but you guys don't have the mathematics behind it to actually calculate it. So what we want to figure out is, well, let's say we gain a z-score, right? Remember, z-score is the bottom portions. Let's say 1.55. Okay. And we want to find the area of all of this now. All the way down there. So this is what we're trying to look for. Okay. We want to find that area itself. Okay. Well, again, right, we don't have the math behind it when it comes to it. So what we're going to do is we're going to use something called our formula sheet. So hopefully you guys looked at the first video, downloaded it, and stuff like that, because we're actually going to use it now here. Okay. So to find the area, under the curve, okay, it is done in 2 steps. Okay. The first step is we want to figure out what are the first 2 numbers of our z-score. So our z-score is 1.55. So what are the first 2 numbers? Hopefully you say 1.5, right? So in your formula sheet, if you guys notice, right, there's a z at the very top. You're going to go down to the first 2 numbers we see. So 1.55. Okay. So if I show you guys that real quick. So here's our formula sheet. So we're going to go down to positive 1.55, which gives us right here. Right, this is 1.55. Okay. Why can't I zoom in? There we go. Get a little bit bigger for you guys. Go. Here's 1.55. Okay. And now what we're going to do is when you go to this side, the numbers across from the z, you're going to go to the very last number. And our last number is a 5. So you're going to go to 0.05 on the very portion. And now you're going to see where those 2 numbers intersect in our portion. And that's going to be our area underneath the curve. Okay. So again, let's go back over here. So here's 1.55, right? We can mark it there. So that's going down. And now going across, we go to the last number in our z-score, which is a 5. And now you're going to see where do those 2 numbers intersect at the value we have. And then hopefully you guys see that it intersects at this number right there, 0.9394. Do you see that? So again, first 2 numbers, you go down. So that is 1.5, right? That's the first 2 numbers. Last number you go across, which is going to be a 5. You go down and see where they both intersect. And it should be 0.9394. So what that means is this area right here, area underneath the curve, is 0.9394, like that. Okay. That is how we're going to find areas underneath our normal distribution. Okay, using the tables by going first 2 numbers go down, last number goes across. Now remember, this also includes plus and minus. So it means z-scores, right, could be negative or positive based on what we have, right? It could be positive or negative, right? So don't forget, just try to force them all to be positive. It could be negative because it's straight out number line. Okay. Now there's a couple of things also we may talk about. You may not have more space here, but I'm going to put them on this other sheet of paper. A couple properties from the z-score formula. Okay. Properties. Okay. So first property is a z-score tells you area to the left of it. Always. Always, 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 always to the left. Okay. So the number we have right now is always to the left. So it means you're always shading to the left of the z-score, never to the right, always to the left. That's the first major property when it comes to z-score. Okay. Well, Besides that one was already talked about, but this is the second most major property when it comes to it, okay? Now, define area to the right. Well, let's go back over here. So let's look about this example. So here's a shaded region. So here's a question for you guys. Do you guys agree that if I have the total area, which is this one, right, which is 15, and if I didn't know how to get this at all, let's suppose, I did not know how to find this area here, but I knew how to find this one, which is 6. Do you guys agree that if I subtract the whole area minus partial area, I get 9? In other words, 15 minus 6 gives you the 9 we're looking for. You guys agree? Hopefully you guys say yes, right? And I could do the opposite. Well, what if I don't know this and I'm looking for this, but I do have this? You guys agree 15 minus 9 gives you this part, which is 6. Yeah. So the question now becomes, well, if I knew this entire sum of the area, well, all I have to do is subtract the what here to get the rest of it. Now, this is the second major part of the normal distribution. The area, or let's just say total area under the curve is equal to 1. Nice and easy 1, right? Because it's a probability, and we'll talk about that in a little bit as well. Okay? Which means if the total area is equal to 1, therefore I can find the area to the right of it. Because I know this plus this must equal 1. So now it becomes a straight algebra problem. So to get that, we know 0.9394 plus, x is what we're looking for, the non-shaded region, must equal 1. So, right, it's just a solving, so subtract it over. So x equals 1 minus 0.9394. So subtracting this gives us 0.0606. Come on. Focus. See if I can do this. There we go. So therefore, the non-shaded area is going to be 0.0606. Okay? And that is how we're going to find areas to the right of a z-score. We first have to find the area to the left and then subtract it from 1, because that is the only way to find areas to the right. Because again, a z-score always gives us area to the left, right? Again, I cannot stress that enough when it comes to it. Now, the good thing is, if you somehow forget, well, guess what? Look at what it says right here. They really tell you what the area is going to give you, right, when it comes to it. You just got to be, pay attention to what the, given to you, okay? So that's always, again, there for you, all right? So what I want you guys to do is go ahead and try questions. Well, actually, let's do one together so you guys can see it. Okay? So the first question is just a little practice problem, right? Just finding areas to the left. Okay. So find the probability of z being less than negative 1.32. Shade the area and ask it to find. Okay. So mu, this is 0, right? So mu is 0, right? There, mu is 0. So we want the probability. Now, the cool thing about this portion, let me give you guys a little hint going forward as well. Okay. So a little start note here. Okay. As we go on these sections and further, when it asks you for the area, it's the same thing as asking for the probability, and it's the same thing for asking for a proportion, which we'll talk about in the later chapters as well. All of these three words mean the same thing. They're asking you for the exact same thing. Okay, that's the nice thing about it. Area is the same as probability, it's the same as proportion in our case. Okay, they do not change. 3 different ways to ask you the exact same thing. Okay, so which means when they ask you to find the probability for question 1, that means find the area. Okay, now this you got to be very careful of. It says z is less than negative 1.3. So let's suppose, again, you don't have to be perfect. So this is, let's say, 1.32. So what are the numbers less than negative 3.2? Is that this side or that side? And hopefully you guys say this side, right? Which means we want area to the left of the z-score, which is perfect because that's the only way we can find out using our portion, right? Only area to the left. All right, so in our case, now we're going to do a portion. So right here is z. First two numbers are what? Yes, negative 1.3. Last number is a 2. Good. So 0.02. And now, where do they intersect? So go ahead and pause it real quick and try it out. Find the number where they intersect. 3, 2, 1. Pause. Okay. All right, so hopefully you guys got it. I'll help you guys out right now. So let's see. Go down to negative 1.3. Okay, and then you're going to cross the 0.02. That's the last number. And what number do they both intersect? It should be this number right there. So 0.0934. So that is our answer here. 0.0934. So that is the area or the probability less than that. Okay. So why don't you guys try 2 and 3 real quick. So 2 and 3. So we'll give it a quick pause and then we'll do them together. So 3, or actually 2, 3, and 4 as well. So 3, 2, 1, pause.